Hello everyone, welcome back to my channel. My name is Piyush and this is video number 5 in the series CK 2024. And in this particular video, we'll be looking into Kubernetes architecture in depth, like all the control plane components, why it is needed, how do they work, and everything else. Till now, we have covered all the fundamentals of containers, why it is needed, container architecture, and we have done some hands-on demo as well. So if you are a beginner to containers and Kubernetes, I would highly recommend watching the previous videos first. If you have some basic understanding of containers and you have done some hands-on, then it's okay to skip those parts and you can start with this one. The comment and likes target of this video are as follows. So comment target for this video is 150 comments in 24 hours and the like target is 200 likes in 24 hours. I'm sure you will be able to do that and show me your support. So thank you so much and let's start with the video. Okay, so let's have a look at the Kubernetes architecture. This might look a little overwhelming at the beginning, but if you reaches till the end of this video, I'm sure you will be able to understand everything in depth, whatever we'll discuss. So on the left side, if you see, we have a control plane or a master node. And on the right side, we have a couple of worker nodes. Now, what exactly is a node? Node is nothing but a virtual machine. So a virtual machine and on which we run our components, we run our workloads, or we run our other administrative components is considered as a node in Kubernetes, right? So this is just another name for a VM. If you see, we have one for control plane and a couple of virtual machine or nodes for worker nodes. Now let's understand what exactly is a control plane or master node. Sorry, my my throat is still not very fine, so I'll be drinking a lot of water in between. I hope you'll be able to tolerate that. So a control plane or a master node is a virtual machine or a node that hosts many administrative components. Now, these components have their own specific purpose and they helps you run your cluster smoothly. So basically consider this as a board of director in a company that helps you run the company, but they are not doing the actual groundwork, right? They provide instructions to other teams, other managers, other team leads, and other resources to work on their behalf, right? So these are the top level management. And on the right side, we have worker nodes. In those worker nodes, we have the actual working happening. Now, idea of running your workload on Kubernetes. Why do we need Kubernetes, right? So we use Kubernetes so that we can host our application on the containers. That's the basic idea. Like, why do you use it? Those containers run on the worker nodes because that is where actual work is happening. But who is instructing Kubernetes to do that work? It's the control plane or master node with the help of different components. We'll look at all these different components. And you see on the worker node, we have something called as pod. Now, what exactly is a pod? So look at this diagram on the right side. Let's say you have a container running. It's an Nginx container. We have already seen what a container is. So let's say you have an Nginx container running and we cannot run the container in a Kubernetes just in its own shell, right? So we have to encapsulate that in something called as a pod. So consider this: when there is a baby in the womb, it requires a sack to protect the baby, right? So that's the pod is that sack. And in that pod, you can have one or more containers. Ideally, like you only have one container per pod, but in some cases you have multiple containers as well. These containers are helper containers or sometimes monitoring agents, sometimes init containers. We'll look at that in one of the later section, but for now just understand you can have one or more container inside a pod, and pod is the smallest deployable unit in Kubernetes, right? So you have deployments, replicas, ad services. There'll be a lot of other objects that we'll be discussing in detail. But for this video, please understand that pod is something that helps you run a container. it encapsulate a container or one or more container in its own, so that those containers share the resources of a pod, and then you run the pod. Okay. So once that pod is up and running, your application inside that container will be up and running. It will be healthy. Now let's look at these components, all of these components one by one. Okay. So first we have nodes. This we have already discussed. On the left side, we have a control plane or master node. In a high availability, in a production environment, we usually have more than one nodes for the control plane as well to support high availability. We'll look that later on. But for now, just understand worker nodes where your workloads are running, your containers, your pods, your all the services and everything will be running. And your master node or control plane node is where your control plane components will be running. These components, like whatever we have seen, like API server, scheduler, HCD, controller manager, these are collectively known as control plane components. Here is your control plane. API server is the center of control plane. That means any incoming request from the client will first reach to API server, and then API server will interact with other components on its behalf, right? So any request that comes from outside, it will first go to API server. So that's the main entry point inside a Kubernetes cluster. Okay. Now, scheduler is something that helps you schedule your workloads. So it receives the request from API server. Okay. So here is your API server, let's say. Okay, and the scheduler receives the request from API server, and then it, let's say someone requested to schedule a pod, right? So the request is received by first API server, and then API server forward that request to the scheduler to find a suitable node for that pod. Right? In a node, there could be several constraints like the CPU, the available memory, available disk storage, and so on. So those decisions are made by scheduler based on different factors, based on request and limits, and there are many other things. We'll look at that later. But all those factors will be considered by scheduler, and then it finds a suitable node for that particular pod. Right. So that's what scheduler does. Now we have another component which is controller manager. So controller manager is the component which is a combination of many different controllers, right? So we have a node controller, we have a namespace controller, we have a deployment controller. So what this does, and there are many other controllers as well. So what these controllers does, or what controller manager does, is make sure that all the controllers are running fine and everything is monitored. It basically monitor the workload, is basically monitor the Kubernetes object and make sure it is up and healthy. So let's say if a pod goes down, it will monitor that particular pod. It will keep restarting that pod because it is continuously monitoring that pod with the help of a controller. So that's what controller manager does. It makes sure your workloads, your nodes, your deployments, everything is up and healthy all the time. Then we have HCD. So HCD is nothing but a key value data store, right? So key value data store, like if you have not familiar with this term, let me explain you a little bit what exactly is a key value data store. So let's say you have a database in like a RDBMS, a relational database, which is in form of rows and columns, right? So let's say you have this row, and then you have this row, you have columns. Okay. So this field is ID. This field is name. This field is, let's say, age. This field is sex. Okay. So this is your employee table. I'm just going to add the details over here. So this is your employee table. You add all the details in different rows for 1 employee, 2 employee, 3 employee, and so on. But let's say we have another employee with the ID 2. Okay. And for this employee, we have to add one more field, which is, let's say, address over here. Right? We cannot add the address unless we alter the table, unless we add one more field over here, which is address. Right? Why do we need to do that? Because relational database, they have a fixed schema, and every record in that table have to follow that schema, right? So you cannot add fields from your side for every single record. So those were the things that were complicated in relational database, and for some use cases where we need to have some random fields or something that is schema less, we cannot follow RDBMS, right? So for that, we have key value data store. A key value data store, which is schemaless, which is a NoSQL database. And in that, you store your values as per your needs in a document format. So this document is generally, a JSON type format, and you store your value in key value. Like, let's say there is one record which says name Piyush, okay, age 35 or 34, I'm not sure, and then address XYZ, and so on. So this particular record will be stored in a document as a JSON format, and it is in the form of key value pair. That means it has a key and a value, key and a value, and so on, right? So as I was mentioning, that etcd is a key value data store, but what values does it store, and why do we need to store the values in that database? So it stored every single information about the cluster. It store cluster information, its state, the details of nodes, pods, configuration, secrets, and every other relevant data in the key value data store. Whenever you make any changes in the cluster, let's say you receive a request from the client and your API server apply that changes, that change will be instantly updated in the etcd database. So every single details are updated in the etcd database, and only API server. So we have API server over here. Only API server will interact with the etcd database, and it will only have the authority to apply those changes in the etcd database. At the same time, the changes will be applied to the etcd database with from API server. But at the same time, if we have to retrieve any information from etcd database, like let's say we want to know how many pods are running in the cluster currently, so that instructions will also be retrieved by API server from the etcd database, right? So this is what it will do, right? So that's the main purpose of etcd database, and it has to be available all the time. In fact, all the control plane components has to be available all the time. And we'll be looking into more scenario based videos dedicated to each of these components. We'll be doing many hands-on in the future as part of this series, so don't worry about it. For now, I just wanted to give you a brief overview and some basic understanding of all the control plane components. So these were those. Now we have two components running in your worker nodes. One is a Kube-Proxy, another one is a Kubelet. Right? So Kubelet is something that receives your instructions from your control plane node. So let's say this is your control plane or master node, and it has different components that we have seen. So let's say you have your API server over here. Okay. API server, what it will do is it will sends the instruction to Kubelet to make some changes in the worker node, and every worker node will have the Kubelet and Kube-Proxy running. So Kubelet will receive the instruction from API server, and then it will act upon that. Let's say Kubelet, we receive the instruction to delete a pod, right? So it will go ahead and it will make the changes over here, and then it will delete this particular pod. right? The pod will be deleted, and then it will provide the response as well. Okay, it will go ahead to the API server, and it will say the API server that yes, this particular pod has been deleted, and then API server will make that change in the etcd database, right? So this is what Kubelet does. It is a node based agent, and which receives the request from the API server, and it enables the communication between, what it did actually, it enabled the communication between a worker node and the control plane node, right? So that's what it did. The next component we have is Kube-Proxy, right? So Kube-Proxy is something that enables the networking within the node, right? It allows your pod to communicate with each other. It basically creates some IP table rules, and that enables the pod to pod networking, and your pods and services can communicate with each other with the help of Kube-Proxy, right? So those were the main things. Now let me try to explain it with the help of an example, like how the end-to-end flow will work in a Kubernetes architecture, right? So I'm gonna delete this section just to make some space over here. Okay, so let's say, okay, let me add a user over here. Let's say you have a user, an external client, maybe a Kubernetes administrator or someone from your DevOps team, and we call it a user, right? That user uses a client, a CLI utility called Kubectl. So we'll see that later on. But just understand Kubectl is a type of client that helps you interact with the cluster and its control plane components. So that user, basically what it did, it uses that Kubectl client and made a request with the API server. Okay, so here it is. So it used the Kubectl client. Now the request, when the API server receives the request, whatever request it is, it will do a lot of things. So it will, I'll just write it on the right side. It will first authenticate the request, then whether this is a valid request, if the user has certain permissions to do that. So it authenticate the request, and then it also validate the request, whether this is a valid request, like if it is even supported by Kubernetes or the Kubectl client, right? So it does all those things. Then let's say the request was to create the pod. Okay, so we use a command such as kubectl create pod and the details of the pod, like its image, port, and many other details. So we'll look at that later on, but just understand for now, the user sends this request to create a pod to the API server. Once the request is received by API server, it does the basic checks, it does the authentication, it does the validation, and so on. And then it basically sends that request to etcd database, okay, to create the pod. Now, etcd database will not, because it's a database, it will not create the pod. But what it will do is it will create an entry in the database that yes, the pod has been created. Okay, so the request will be sent to etcd database to add an entry inside the etcd database. Now, once you did that, once the entry has been made, then etcd server sends the response back to the API server that yes, the entry has been created. Then we have a scheduler running all the time, right? So scheduler is monitoring the control plane all the time. Scheduler finds that, okay, there is a pod that needs to be scheduled on a node, right? So it finds that yes, I need to make that scheduling arrangement. So scheduler basically says to API server that yes, I found a pod. I found a node, okay, and go ahead and schedule the pod on this node. Okay, now the scheduler made that request to the API server. Now, the next part is to schedule the pod, right? The pod has not been scheduled. We have the entry in the etcd database. Scheduler found that we have a node available for this particular pod. Now it only sends the instructions to the API server. Every component sends details or requested metadata to the API server, and API server is the one who takes the decision. So then API server interacts with kubelets. Okay, let's say it found this particular node, node A. Okay, that's it. Schedule the pod on this node. So API server reach out to the kubelet of this particular node. Hey, I have a job for you. Schedule this pod on your node. Receiving that request, kubelet will schedule the pod right on this particular node, and then it will send the detail back to API server that pod has been created. Now API server will then add the entry in the database, in the etcd database, that yes, pod has been created. Now all the work has been completed, and then it finally sends the detail to the user that the pod that you have requested has been created now. Okay, so user will finally receive that request. Okay, so let me delete some of the extra arrows that we had so that it will become more clear. Okay, so this is what it did, and it follows the similar case. If let's say instead of create pod, the request was to get the pod, to check how many pods are running in the node. So what it will do, okay, API server will receive the request, it will authenticate and validate the request. Okay, once the request is validated, it will get the information from etcd database. Okay, so user which is authenticated has requested how many pods are running in this particular namespace. So it will retrieve that detail from the etcd database and it will send the response back to the user. In this case, it does not have to check in the cluster for the number of running pods because this is a database with every single detail stored in it. So it just have to look inside the database and then it will return with the results. So that's what it does. To recap, what have we done? So we have seen it will first authenticate and validate the request, and then it will retrieve and update the data in etcd, right? Retrieve and update in etcd. Then it will take instructions from scheduler, which is continuously monitoring if there is any pending pod to be scheduled, if there is any pending action item for me. And once it found that, so it will instruct API server to schedule that pod. Now it will also provide the node details, right? And once it has, API server has the node details, it will send the request to Kubelet. Okay, I found a node and I see you have some resources. I see you are the best fit out of the available nodes, and go ahead and schedule this pod on your node. Okay, and then it will send the response back to API server. I hope it is still visible. Yes, okay. We'll send the response back to API server, and API server then send the response back to client. Okay, so this is generally the workflow that it takes, and this is how it works. But if you still have doubts, we'll be covering that in detail, so don't worry about it. We'll be looking at each of these component, how it works, and we'll simulate some failure scenarios so that you will know where to look for if you're getting certain error, or which component is responsible for doing this particular action, and so on. So everything will be clear. But for now, from a high level, just try to understand the flow that it takes, the basic purpose of each of these control plane components, and the components that are running or worker nodes such as Kube-Proxy and Kubelet. So that's the basic overview of Kubernetes architecture. And I hope you found this video valuable as well. And let me know in the comment section what you think about it. And if you have any doubts, any questions, then yes, feel free to reach out to me in the comment section or through our Discord community server. We have a dedicated channel for CKA 2024 help. So try to paste your question over there with all the details, and someone from the community or myself will try to help. So thank you so much for watching the video so far. I hope you are having a good learning experience. If you did, please try to complete the comment and likes target. And I will see you soon with the next video. Thank you so much for watching. I hope you have a good day.